Hello, algebra mathematicians. Let's start on the warm-up, which covers the material from yesterday, one-step equations. We take a look at this first one and we see 7x. We ask ourselves the first of the two questions, which is what is the number doing to our variable? In this case, the 7 is right next to the x. We know that means multiplication. The second question we ask is how do we undo that? How do we get rid of it? So to get rid of multiplication, we're going to divide. So we divide by 7 on this side. If we divide by 7 on one side, we have to do the exact same thing on the other side to keep the equation balanced. 7 divided by 7 is 1, or just 1x. 28 divided by 7 is 4. Simple enough, one-step equation. On number 2, the variable's on the right side this time. We ask the first question, what is the number doing to our variable? In this case, it is adding. So the second question is, how do we undo that? The opposite of adding is subtracting, so we do minus 6. If we do that on one side, we have to do it on the other. The 6 on the right cancels, and we're just left with x. The inequality stays facing the same direction, and 5 minus 6 leaves us with a negative 1. As a reminder, since the large side of the inequality is facing the x, we could read that as x is greater than or equal to negative 1, or if we read it from left to right, it would be negative 1 is less than or equal to x. Alright, let's move on to today's material, which is two-step equations and inequalities. On example 1, we have an inequality. We're solving for the x. One thing that may become helpful to you is to circle the variable you're trying to solve for. There are two numbers that are in the way. This 7 is not in the way. That's on the other side of the inequality from the x, so we don't care about that one. The two numbers that are in the way are the 4 and the negative 1. Now the general rule about how do we have to get rid of both of them, but we have to get rid of one of them first. The general rule is going to be you get rid of whatever's being added or subtracted. This negative 1, or this 1, is being subtracted. So how do we get rid of, how do we undo minus 1? By adding 1. And if we do it on one side, we have to do it on the other. The 1's cancel. 7 plus 1 is equal to 8. Inequality stays facing the same direction. 4x. What does it mean when a number is next to a letter? It means multiply. How do we undo multiplication? Divide by 4, divide by 4. X. The inequality faces the same direction, and 8 divided by 4 is 2. So to read that from left to right would be 2 is less than or equal to x. On example 2, we have an equation. We're solving for the variable. There are two numbers in the way, the negative 5 and the 7. We get rid of whatever's being added or subtracted first. That negative 5 is being divided because it's under a fraction line. This 7 is being subtracted. So we ask, how do we get rid of subtraction? We add plus 7. If we add on one side, we have to add on the other. We're left on the left with the x over negative 5 equals 7 plus 3 is 10. And now we have our second step. On the second step, we ask what is the number doing to the variable. Right now it's under a division line, which means it's dividing. The opposite of division is multiplication. So we're going to multiply times negative 5. If we do that on one side, we're going to do it on the other. Multiply times negative 5. The two negatives on the left cancel because negative 5 divided by negative 5 is 1, or just 1x, equals a positive 10 multiplied times a negative 5 is equal to negative 50. A positive times a negative is a negative. Alright, let's work on example 3. Here's the variable x. We have to get rid of both the 4 and the 5. We get rid of whatever's being added or subtracted first, which is this 5 hanging out over here. It's not the 4, because the 4 is multiplying times the x. The x is the thing we're getting rid of. So we get rid of this 5. Now there's nothing in front of this 5, and so that sometimes throws students off. Sometimes they might try and add plus 5, but that wouldn't cancel the 5. We want to get rid of it. So that's a positive 5 out front here. So to get rid of positive 5, we go minus 5, minus 5 on both sides. On the left, we're left with 4x, and on the right, we have negative 15 minus 5. There are two negatives. We're adding them together, or negative 15 minus 5. In either case, they join up, and we have negative 20. Now we're on to our second step. We still need to get the x on its own. What is the 4 doing to the x? It's multiplying because it's just sitting next to it. Divide by 4 to get rid of multiplication. X is equal to negative 5. The final example. Here we see our rule where we want to get rid of whatever's being added or subtracted. We want to get rid of that first because we're solving for the x. But in this case, we can't get rid of that negative 5 first. The reason we can't is because it is being divided by 3. Both the numerator, everything in the numerator, both the x and the negative 5 or minus 5 are being divided by that 3 underneath it. So we can't get rid of the 5 because it's trapped by this fraction line. It's like there were parentheses there. So we have to get rid of the 3 first. This is one of the only times that we're going to get rid of the division before we get rid of that adding or subtracting. So what is the 3 doing to the x right now? Well, it's under a fraction line, which means it's dividing. The opposite of dividing is multiplying, so we're going to multiply times 3 on both sides. 3 divided by 3 is 1, or just x minus 5. And then the less than symbol stays there. 17 times 3 is 51. The second step to solve the question, we ask what's this 5 doing to the x? It's being subtracted, so we're going to add to get rid of it. Plus 5 on both sides. X is less than 56. All right. Please raise your hand if you have any questions, and good luck.